Prism. A prism is a transparent medium bounded by a number of surfaces such that the surface on which the ray is incident and the surface through which the ray emerges are plane and non-parallel. Let us look into this definition and try to understand how does a prism look like. Take an example. Let me draw one prism here. This triangular shape object is called a prism. Right now I am showing you only the front face of the prism. Okay, let me show you some other view. So this is the prism as you see from from little bit side. So now the different sections of the prism has a different name. This section of the prism is called the principal section. Principal section. A prism will have two principal section. Okay, and these are, so if I name this A, B, C. So here is A, B, C. This is D. This is E, and that side hidden side, that is E, F. So A, D, B, C and D, E, F are called the principal sections of the prism, and other than that it has two refracting surfaces. So this is one refracting surface and this side is another refracting surface. These two are the refracting surfaces. Now what the definition says is that on which the ray is incident, transparent medium bounded by a number of surfaces. So you can see we have 1, 2, 3, 4, 5 surfaces. This is called the base of the prism. That is B, C, D, F is called the base of the prism. So that is also one surface, right? Then such that, okay, now the ray is incident, the surface on which the ray is incident and the surface through the ray emerges are plane and non-parallel. So you can see they are intersecting. These two planes are non-parallel, that is C, A, C, D, E and B, A, E, F. These are all non-parallel, right? So this kind of shape is called a prism. Okay. Now we will see the refraction through prism. Let me draw one more prism now. Wait. So imagine this is a prism and a ray of light is incident in one of its surface. This is the ray. This ray at this surface, let me name this surface A, B, C. Let us say this is the normal to the surface. This is normal to the surface. This ray, the incident ray, undergoes refraction at this face AB, and after refraction it travels with a constant velocity within the medium and get again refracted at the interface AC, that is at the second refracting face AC. So again this is the now normal to the prism. Let me extend this normal. these are the two normals, and if this prism was not present, the ray would have traveled like this. This should have been the original path of the incident ray, but due to the presence of the prism, the ray undergo refraction in two surfaces AB and AC, and finally it emerges out at, let us say, at this angle, somewhere like this. Clear? So then if we extend it back, that means this angle must be the angle of deviation. This is the angle by which the ray has got deviated from its original path. So this is the incident ray, and this is how it is traveling through the prism, and it is emerging out. This is the emergent ray, okay. So now, so the ray, let us say the ray is incident at certain angle I, and it is coming out, emerging out at certain angle E, okay. Other than that, that means if I is the incident angle, that means this must be the angle of refraction. Let us name this as R1. Similarly, let us say this is the incident angle for the second interface. So this is R2. Clear? So what do you think this will be? How much is this one and this one? To find it out, what we can do is this. You see, let us name this different edges, different thing. So then this is A. Let me name this point as I have already written BC. Let me name this as D. This is E. This point is F. This is G. Okay. So angle. So what do you think this one? This one will be, how much is this one? This angle GDF will be, that is this one will be I minus R1. And what about this one? Similarly, this one should be equals to E minus R2, correct? So now we will establish a relation which will give us the angle of deviation in terms of the incident ray, the incident angle, the emergent angle, and one more angle, that is called the prism angle. This angle is called the prism angle, angle A. So let me go back. I forgot to tell you, this angle A is called the prism angle, okay, where the two planes in meet is called the prism angle. So we will try to establish a relation between I, E and A for the angle of deviation. So looking into the figure, let us say, now look closely, then can I write from, so can we write I equals to, what can we write angle delta equals to? Angle of deviation delta, angle of deviation delta will be written as sum of what? It is the exterior angle for the triangle GDF. So delta will be written as sum of interior angle. So sum of interior angle would be I minus R1 plus E minus R2, which we can write as I plus E minus R1 plus R2. This is delta, correct? Now from triangle, now from the quadrilateral, from the quadrilateral ADEF, ADEF, can we write angle A plus angle E must be 180 degree, angle A plus angle E equals to 180 degree, because in case of quadrilateral angle, two opposite sum of two opposite angles are 180 degree. Okay. Also from triangle DEF, also from triangle DEF, it is this triangle, this one, this triangle, we can write R1 plus R2 plus E, R1 plus R2 plus E, angle E equals to 180 degree. from this equation can we write angle E equal to 180 minus A? So, if we substitute this value here, what do we get? We get R1 plus R2 is equal to A. So, knowing the value of A, if we substitute in the first equation, let us name this equation as 1 and this one let this equation be 2. So, from 1 and 2 equation we can write delta equals to I plus E minus A. So, this is the angle of deviation for a prism with angle of incidence I, angle of emergent E and prism angle A. Carefully if you see that it depends on these three factors, right. So, now if we try to plot a graph, if we plot a graph between delta and angle of incidence, this is what you are going to find. You are going to find the graph is something like a U shape, although if you open a book it will show you something like this, a perfect U like this way, but actual practice when you do in your practical you will find something like this, something like this. So, two things to note from here. Let me name this. This is the angle of deviation, this is the angle of incidence. Now, two things to note from this graph. So, when you plot the values of delta with angle of incidence, you will see that for every for every two values of I angle of incidence, two values of angle of incidence, there is one angle of deviation, isn't it or not? You can see. However, this is the first thing to observe. Second thing to observe, that there is one angle of incidence for which the angle of deviation is minimum. Okay, there is one angle of incidence that for which this is minimum. We call this minimum angle as angle of minimum deviation, and when this happen, this is only possible when I is equal to E. So, what two things to note here from what, that at every time for every angle of incidence, for every angle for every two angle of incidence, there will be one angle of deviation, and there is one angle of incidence for which the angle of deviation will be minimum. When this happen, we will call the refracted ray to undergo minimum deviation. So, when this happen, let us look at the prism once again now. Imagine this is the prism. When this happens, that means the incident ray is parallel to the base of the prism, inside the prism. So, that means this one and this one is parallel, right, because these are the normals, this is I, this is also I, right, and you see delta equals to I plus I minus A. So, we will look into this relation in the in future video, but for now you can see this is the graph of delta M, delta versus I. So, you can see now why there is a 2 points, why there are for every two angle of incidence, why there is only one delta. So, to understand this can be explained from principle of reversibility of light. Imagine that this is a prism, I take one prism here, this is a prism, this is the incident ray, it undergoes refraction at this face and again it undergoes refraction here, but now we place a mirror. So, this can be explained. So, if I place a mirror, what will happen? This ray will retrace its path backward. So, that means at this case also its angular deviation will be again delta only, correct. So, that is why for every angle of incidence, this is I, this is E, or vice versa, you can see there will be one angle of deviation. Okay. So, So, this is the important things to note, and do not forget that when this line is parallel to the base of the prism, the ray is said to be undergoing least angle of deviation or minimum angle of deviation. So, delta m is minimum angle of deviation. This means the ray is getting deviated by the least, deviation is least. That means this angle is less, this delta is very less. Understand? That is it. We will look into some other topic and numericals.